All right. So before I start, I just want to acknowledge all the people that are working in my group, because I'm going to use some of their work as examples. So we're based in Sophia Antipolis, in the south of France. We are a joint group between INRIA, the University Côte d'Azur, and CNRS. And one point I want to make, which is important, and is going to be important in terms of knowledge acquisition and how I see its future, is that one thing I really like in my group is multidisciplinarity. And I will come back to that, because I believe there is no future for knowledge acquisition without multidisciplinarity. So in my group, you find people in NLP, multi-agent system, interaction design, and so on, knowledge representation. And of course, they have at least one thing in common. They all contribute to one of the steps of the life cycle of a knowledge graph. Okay, so that's what unites them. And I want to thank them for all the examples I will borrow from them. Okay, so yes, Oscar, we met in 2000. This was the call for paper of 2000. I'm sorry you missed that one, you cannot submit anymore. And yes, we were young, okay? No love, please. So I was a PhD student at the time, you can see, because I still had hairs on my head. And I was part of the local organizer. Now, 2000 was an important year, not because it was in south of France, but because it's the year we decided to change from the knowledge acquisition workshop to the International Conference on Knowledge Engineering and Knowledge Management. And you can see it in the call of that year: engineering, sharing, corporate memories, keywords of the time, but also agent system, web-based system, and internet-based system. And acquiring is still here, of course. But that's the shift. That's the moment where we went from that pure focus on a workshop on acquisition to a broader scope, okay? The local organizer was my supervisor, Rose Dieng. She organized the local EKAW. And why do I mention her here? Because at the same time, whenever she was giving a keynote, usually the first slide would be this one, with a quote from Yuval Shahaj that she would use all the time, saying, if you're not acquiring knowledge, you are losing it. And you can still feel that at the time, the pressure was, we must acquire, we must build knowledge bases. We must get that knowledge, otherwise we are losing things. So that's the state of mind still in 2000. Then, 12 years later, with the young lady sitting over there, Natalie Osnak, we wrote a paper in which we said, after this decade, there had been a shift in the community. Clearly, there has been a shift from early work that comes from the amount of data that was now available, okay? So the initial problem of knowledge acquisition, of having too few sources, had shifted towards the problem of too many sources, too big, too diverse, too dynamic, too distributed, blah, blah, blah. New challenges arise in addressing data and schema heterogeneity and provenance, incoherence, and social life cycles. All challenges are increased tenfold by the scale of complexity of the web, acquisition, formalization, evaluation, evolution, and so on. So clearly, a decade after, there had been a shift from the moment we were trying to build big knowledge bases to the moment that, okay, we have a lot of them, they are heterogeneous, we have a new problem, which is to manage that. And so, yes, what had happened is that now knowledge acquisition had to evolve in the age of an hypermnesic web. That was a big change. Okay. Now, I realize that most of you are younger than the web. If I take the world population, in fact, we are now at a time where most of the people are younger than the web. So I understand most of you didn't know a world without the web. But it wasn't the case in the 90s, when we had ontology, engineering, methodology, and that. And so this meant we had to evolve and to adapt to that. Things change. For instance, this is an object I still have in my office, and probably no one of you ever had. This is the Yellow Pages book of the web that you could buy to find addresses where to go online. Probably, I still have one. Some of the addresses still work. You know. You probably never saw that. This was killed and replaced by a verb. This was killed and replaced by a transitive word, which is to Google. Okay? We have a verb now for that, and we don't need these Yellow Pages anymore. To the point where also most of you never saw this endangered species, which is the no result found page. At the beginning, we were getting that 1 time out of 2, but you never saw that page almost. There is always some kind of answer to your query. That's what the web changed. And in parallel, at W3C, so I have to mention, I am a representative of INRIA at W3C, and many people in my group are inside W3C, so everything I'm going to say is going to be biased toward the web. And so what happened also in parallel in the year from 2000 to 2010 is the development of the semantic web stacks and the standards and the linked data online. And that resulted in the fact that after having an increase of the number of websites in the 90s, we had an explosion of the number of data sets in the following decade. And that was the new landscape for knowledge acquisition. So this led us with Jim Handler and Dean Aliman to write this sentence in this book, where we said that we have learned from the web that typically people don't want machines to behave like experts. There's something we also knew in the knowledge acquisition workshop, when we went from expert system to knowledge-based system. The idea was this: the people don't want an expert sitting in their machine, they want to be expertized by the machine. So they want to have access to information so they themselves can exhibit expert performance at just the right time. So this led me to choose, when Laura and Oscar contacted me, an initial position for this talk. And my initial position was that I will consider that knowledge without intelligence is a highly perishable resource. Inversely, intelligence without knowledge is doomed to stagnation. Which leads me to conclude that intelligence and knowledge and their evolution have to be considered jointly, whatever the form of intelligence we are talking about, natural or artificial. Why do I say that? Because I want to reuse a word from the history, because in the 50s, we have these terms, artificial intelligence, which is coined, especially by the group around McCarthy. But at the same time in history, 2 of the terms are coined. One by Ashby, which is intelligence amplification, and then the one by Engelbart, Engelbart, who is the inventor of the mouse, for instance, the pope of human-computer interaction, which is intelligence augmentation. And the idea, the difference, is that they start from the human. They start from an existing intelligence, and they want to augment it. Right? They don't want to create some artificial intelligence and then ask themselves, how do I put the human back in the loop? No, they start from the human and say, how do I help that human? Maybe using some intelligence artificial methods. And this idea of augmentation of intelligence, that's what triggered the title of my talk. So one of the first questions I want to ask in this talk, and I want to explore, is should our focus be shifting to knowledge augmentation and amplification, meaning our knowledge? Putting back the human. So in other words, could our ultimate goal be that we augment our knowledge? Just like people are maybe afraid of intelligence, artificial intelligence result right now, we could ask ourselves, did we miss the point? The final point, which is us, in knowledge acquisition. So I'll divide the talk in 4 parts, which is going to take me the next 2 hours, so don't worry. First, I'll talk about knowledge graph on the web. Then I'll talk about the different AI approach that participates to the life cycle of this knowledge graph. And I will insist on the growing importance of hybrid approaches. Then I will talk about the problem of maintaining or reintegrating humans in the loops in these systems. And finally, I will go up to the social dimension, because it's not enough to maintain one person. We are interacting with communities, all right? So, knowledge graph. I don't need to make the point about knowledge graph. You just look at the stats. Clearly, the keyword is buzzing, it's augmenting. So it's a very important topic. It's not as visible as machine learning these days, but clearly, when you talk with industry, knowledge graph is a keyword. Everyone in this room, all the talks I've listened to, all the groups that are represented here, they've been publishing graphs, ontology. So everyone here is doing their share. In my group, for instance, we published the French chapter of DBpedia since 2012. And everyone here is looking at ways to augment this knowledge graph, extracting new knowledge, adding new thing, learning new ontology. So an example of extraction we perform in our group is the history of Wikipedia. So for a page, we don't only extract the content, we extract the history to know what happened on that page, which can help us know how fresh is that knowledge or not, or is something happening in that domain or not. Okay? And we've done that in music. It's linked to the talk of Vanessa yesterday on multimodality, where in music, for instance, we analyze the lyrics, the metadata of the music, the audio, and we merge that in one graph to help people analyze the music and replace them. We've done that during the crisis in lockdown on COVID, where we did entity analysis on medical article, and also extracted argumentative components to help people understand what is inside, what is the claim being made inside the article, and so on. So we're producing many knowledge graphs to the point now one of the problems we have is to find them. Right. So one of the things we now have as knowledge acquisition tool is, instead of creating a graph, does it exist already? Is the graph I need exist already? Which is the problem of crawling on the web. So we worked on that problem using a machine learning technique to predict whether URI is going to give you RDF or not before you make the call. Because what costs a lot in terms of computation is the network access. So you want to do it when you have a chance. So you can train a machine to learn the schema of the URI of data and say, oh yeah, there is a good probability this will dereference to some RDF data, go ahead. Or no, there is a low probability, you want to schedule that for when you really have time. Which has a big impact on one thing, which is, for instance, to build index. So for instance, in several of the group, I can mention the one of Oscar, they've been working on federated query. As soon as you have that, you have an index and you can query distributed sources, which is nice. Okay? But again, I want to insist on the fact that we are not in the 90s, we are on the web. So what can we do with the web that we couldn't do before? Well, for instance, in this project, in Index, Mr. Mayo, Pierre Mayo, is working on a GitHub-based index where what you can do is put on the GitHub site the rules that allow you to extract the indexing data that are important for you in a knowledge graph. So you want to say, I want to know what are the vocabulary in a graph. That's important for me to optimize my join, for instance. And you push that rule to the index. And the next time the index engine is running, it will apply your rule and add this data to the index so that it will make it available for all the known endpoints and for you to use in solving your queries. So it's useful for federated query, again, for instance, for calculating quality metrics. If you have a metric you want to calculate, you push it to GitHub and then it's added to the index, for instance. So it's useful for machine, but it's also useful for human, because on top of that, you can start also visualize the state of the knowledge graph you have online. So this is a data set. The index currently contains 460 knowledge sources. You can know where they are, for instance. And when it's green, it means we use two different ways of calculating the geolocation. When it's green, it means they match. When it's red, it means the two different means gave a different answer. So it gives you an idea of how reliable it is. This is the social network of the knowledge bases through this shared vocabulary. So you know which one has a vocabulary shared with another one. And I'm not talking about declarative vocabulary, the one which is effectively used in the data and therefore has an impact on joins. So we distribute knowledge in this community, we distribute queries, we distribute reasoning, but are we distributing everything we should be? Are we distributing the entire knowledge acquisition as we should be? Are we distributing the correlation? Are we distributing the modeling? That I'm not completely sure about. That's one of the questions I will leave you with. Can we do better? Can we use the web to help us on this task? Just to give you an example, to push a little bit the imagination, there is now a web standard, W3C, that works in your web browser that allows you to push a trained model to the web browser itself. So you use the web browser to run the inference of your model in the web browser. What I just said is that at any moment using that, you can use any web browser in the world running on a machine and push an AI model to be run on that browser. So for instance, you could perform some knowledge acquisition at the edge of the network, at the edge of the web. It's a way to do edge AI through the web. What is the implication of knowledge acquisition, of having this ability now? And among the other questions I wanted to ask, what are the types of knowledge we are missing? Because we are good at, for instance, at every knowledge representation conference I go, there is something about health data. Clearly, biology are pioneering. We have had gene ontology and things like that. But are we missing other domains? Are we focusing on domains that we know and missing some other very important knowledge? So this question came to me in a project which was called ALUF, where we were asked to bring knowledge to a robot to improve the behavior of a robot in a home situation. And the first behavior was we wanted the robot to go to the most likely room to find an object. Instead of just scanning the entire room with visual recognition, if I ask, that's Vladimiro. Huh? If I ask Vladimiro, go and take a spoon, he will probably not go to the bedroom, right? He's going to go to the kitchen, most likely. I want the robot to do the same. But for that, I need this common sense knowledge. And we didn't have that, right? This was a complete blind spot. So we had to develop an NLP approach, train it on children's books and things like that, for the robot to learn where to find things, and then we publish it in RDF so that it is now shared between other applications and other robots. But that's an example of knowledge where clearly we had a blind spot. Uncertainty is another example. We've been working on representing and negotiating uncertainty, and if you look at the knowledge graph on the web, very few of them give you how certain is the knowledge they have, how much of the extraction similarities or measures are available for you to know before you use that knowledge. And to give you a last example of knowledge I think should be looked at, I'm going to use this book. So it's a Chinese book. This is the title of the Chinese book here. It reads From Point to Point. It's by Xu Bing. And the content of the book is this. It's entirely written in emojis. So it's a book anyone could read if you understand emojis. It's completely based on a semiotic system, right? And that leads me to say that maybe one of the blind spots in our community is the semiotic dimension in knowledge model. We are not good at capturing the semiotic dimension. Semiotic knowledge acquisition is important in general, and it's extremely important so when you want to build intelligent interfaces on top of this system. Because as soon as you want to go back to the user, you need some kind of semiotic system. And if you haven't acquired that knowledge, it's becoming extremely difficult. And also, another type of knowledge which is missing a lot, although we have ontologies for that, we have Provo, we have all sorts of things to trace knowledge, but many sources don't tell me where the knowledge comes from. And I need that before making a decision, right? I need that because some of the knowledge, for instance, extracted from the web may be interesting. This is the correlation between the Center of Disease in the US about the flu in orange, and the symptoms terms for the flu used in Google. So clearly there's something to be done. Clearly, if I had a job at the CDC, I would be worried, right? But not all things work like that, and I need to know that. And there's an excellent website called Spurious Correlation that shows you correlation that really should not be causation. And this is an example of people, and I'm seeing people using correlation all over the place and making all sorts of mistakes and then letting the system take decisions. I am worried about that, really. And I need to know that. I need to know where does that knowledge come from, what methods, how we went from a correlation analysis to a causality before I say, okay, I'm going to use that. And the last example I wanted to give is the bias that I introduced by these in the data set. So many people in France make the mistake of using internet instead of web. They will say internet instead of web. Right? And as a result, the translator have learned that a good translation for the World Wide Web in English is internet in French, which makes me mad, really mad. Yeah. Every time I teach the web, I start by that, I say, okay, let's make it clear. These are two different things. There are two different people that got two different Turing Awards for that, all right? So let's make that clear. And this is an example of bias that I cannot correct. So, just to conclude that first part, is there a streetlight effect in our community? Should we acquire other types of knowledge? This is something I think we should consider taking a step back. Okay, second part, combining different AI approaches for the different steps in the life cycle of this knowledge graph. Oops, no. So, many of you are using knowledge bases, knowledge graph, ontologies, and then reason on them. So many of you are deducing new data and adding new data in that system. So many of you also use learning approaches to improve that data, to find a missing link in a graph, to extract a graph from a text source, and so on. Okay? More and more of you are doing the two at the same time. So combining, for instance, in parallel to improve their data, symbolic approaches and neuronal approaches, connectionist approaches, for instance, right? What we see less, but is coming, is people combining them on the same data set and using the input of one cycle as the output of another one, so as to take the best of both worlds and reason, and then learn on what you obtain as reasoning, and then reason on what you learn, and so on, right? And what the web is bringing to the picture is that we can now do that using the standard of the web, such as RDF, through the web. So it could be the method of LoRa, which is then used as a result by Oscar, which is then used as a result from my methods through the web. So the web is allowing combining AI on a global scale. And when I say combining AI, it's not only the input of one goes to the other one, but the model or the parameter of one could have been auto-supervised by the method of another one. The schema of one could have been generated by another one. It's every level which can be coupled in AI through the web. So most of the application right now of hybrid approaches are still on augmenting the data of knowledge. I want more data, I want more triple. I don't know what we people have with triples and counting triples, but anyway, we want more. So it can be extremely interesting and useful. This is an example from IBM Dublin on smart cities, where one of the collaborators of the team, Freddy Lecoué, worked on the results here of the sensors of the city, of the smart cities. And one of the first problems he asked himself is, should I use the raw graph, or should I augment this data with knowledge before, so that I will be able to do more intelligent processing? And that's what he did. He augmented it with DBpedia data, with data from the web on event. So when he was seeing something going wrong on a sensor on the road, it was not just that he was analyzing that, plus the fact that there was a concert of Madonna near that street. And that's what he was feeding to the system in order then to have an analysis and suggest also some of the reason why we were seeing something on the network. Another example, which is a bit close to one of the example of Vanessa, also because some of the results here were limited in our case too, where we looked at hospitalization prediction from physician record. So we take the physician report we have on top here, and we add to that knowledge about the disease, about the drugs or anything, before we learn to predict the hospitalization. And we look at the impact of that to see if we are better or not at improving the prediction. What we found that, yes, sometimes we're better, but sometimes we are worse. And in fact, this knowledge injection works as an amplifier. If there were good clues and you were good at predicting, it's going to amplify that. If you made a mistake, it's going to amplify the mistake. And I don't want to talk only about the multi-agent, the machine learning approach, I want to talk about AI in general and combining AI in general. So for instance, this is the work where the people are working on evolutionary approaches to learn axioms from RDF. So they consider that the genetic aspect of the population are defined using the grammar of RDF and OWL. And they make a genetic algorithm that changes the genetics capabilities of characteristic of the population to learn population that extracts the best axiom and the fittest one survives, the fittest axiom survives, if you prefer. What I want to point here is that when we say hybrid method, we shouldn't think just, okay, symbolic and neural. No, there are many, many AI other things that can be combined. The second task where these techniques are applied is improving the data we have, the quality, the coverage, and the knowledge in it. So one example of that, for instance, is we have this data from the Minister of Culture in France, which is essentially the collection of Le Louvre Museum in Paris. We have the images and we have the metadata defined in a thesaurus. And what you can do on that is that you can query this RDF part to create data set to then train dedicated recognizer to find horses in sculpture. And you can do that using the thesaurus, because you know that a horse may appear where you have a chevalier, a cavalier, okay? And then when you have that, you can do the other way. You take your classifier, you apply them to all the images, and you put the results in the RDF. And then you can contrast what you obtain by reasoning and what you obtain by learning. And why is it interesting? Because the differences may tell you you have found a silence. Here there is a horse, but it wasn't in the metadata. Or you have found a noise. Here the metadata says there's a horse, but there's no horse here. By putting them, combining them, you detect errors in the data. And I want to insist, because I can see some people sometimes almost despaired and saying, okay, it's the end of knowledge representation, knowledge system, everything's going to be it's almost an Oedipus complex that is lived by some of us. And I don't believe in that, really. I think that the knowledge which is acquired by a neural network really is not knowledge for us, because it's actually qualified as latent knowledge. And that's the biggest problem for us. It's the biggest problem because explainable AI is not just something they want, it's something we have been wanting from the beginning. We, in this community, have been talking about actionable knowledge for a very long time. Why? Because only actionable knowledge allows us to make decisions that we can defend. Oh, I'm going to skip that one for the sake of time. Yeah, just mentioning this one. It's not just our community, it's not just wishful thinking. If you look at some of the latest works of Google, such as this one, they also are slightly changing their direction. They are coupling symbolic system and neuronal system. So for instance, here is an architecture I really like that they proposed, which includes in it a symbolic memory. And the task is changed. It's to answer questions, but the task is not just to learn from pure text. The task is to learn from natural language how to fetch the right triple which is going to be giving the answer. So the task is slightly shown. And the interest of that is that you can include databases as big as you want in here, and you can update and augment this memory at inference time. You don't need to retrain the system. So, knowledge acquisition can go deep, but it can go deep in many different ways. You know some of the examples, and knowledge acquisition has things to do for improving the quality of the inputs and the bases that are used by the systems. They can also be used from a methodological point of view. I mentioned people doing knowledge-based auto-supervision, for instance, but I think it can go beyond that. Knowledge is more than an input or an output or a parameter. In fact, I could claim that a neural network itself can be seen as a knowledge graph. And it's been done. These guys here provide an ontology in OWL to describe the neuronal network and exchange it in RDF. So suddenly we change things. The network is in our data. We are not the data of the network, they are our data. And we can reason on that. You can choose to change your model by reasoning on the RDF representation of the model, right? So we in knowledge acquisition can work on acquiring, representing, exchanging meta-knowledge for AI and the enclosing decision workflow, because the AI systems are not just in the air, they are inside decision system, which are still written in good old ways, right? Including our ways. Okay, third part, how am I doing? Not too bad. Putting back the human in the loop. Did I lose anyone? No one complaining so far? Right? Good. So, to illustrate that, I'll talk about the work of Marco and Aline here. They work on linked data visualization pipeline. So instead of going through the pipeline with you, I'm just going to give you an example of what this pipeline is used to generate. It's first used to generate interfaces that we can use, especially knowledge engineer. For instance, interface for visually mining RDF graph. So here is one of the snapshots of the interface which correspond, in fact, to that Sparkle query that you don't see, but which is behind that, allowing you to analyze a co-starring network, for instance, on DBpedia. Another example of interaction is the follow-up query. Follow-up query is whenever a user has been looking at some data, and from the result, he wants to create a new query that takes into account this result. So, for instance, he found article about the coronavirus, and now he wants to see which one of them also talks about cancers. Yeah, so it's a follow-up query. Right? So that's an example of follow-up query interaction you have there, with all the mechanism to trace the query, to go back, just like you would do in a web browser, to replay it. You can use also this to do data exploration quality, so finding missing data, duplicated. All these are interaction that would be for us, knowledge engineer, for instance. And then you can go up to the end user. So for instance, on the musical data I mentioned at the beginning, you can do temporal analysis of a linked data RDF about a group and an artist. So for instance, the example here shows you from that data set, RDF, what is the work done by Freddie Mercury, what is the work done by Queen, and what they have in common, and when did he go solo, for instance. So here he went solo, for instance, and we know. Right? And finally, all the process we have, so for instance, rule extraction, rule mining, also give rise to interaction. This is an example of visualization which was created to help an expert analyze the rules that were learned on the system and try to see if some of them are relevant for his domain. But interaction goes, I think, much beyond that, especially if you really want to go toward this augmentation, our augmentation. So for instance, you can start to design interactions that are designed to help us learn things. So you can start to design serious games on top of this linked data, like this one, to train young students to learn geography. And we have the same approach for junior medical students to learn anatomy. Right? All this is available, and the idea is now, okay, we have acquired that knowledge in the machine, let's put it back in the human brain. Let's help them. And when you do that, what you can do in the next stage is look at how a student does at a question and use that and the knowledge graph you have about the student in question to try to predict what would be the next best question to ask him to make him go in the right direction. So you can learn to recommend a path to maximize the chances to get the student from one level to another. So let's look back in the mirror. This is something we would see 20, 30 years ago. This graph, the Nonaka cycle, was present at EKAW at every conference. I would see it. Okay? This is a graph that in knowledge management explained, this is a figure that explained how knowledge is transferred from one person to another, then to a person to a group, then to the group back to a person. So that's the social way we learn, okay? And what I like in this graph is that you could tick it now and use it to see how are we doing now, right? So for instance, Nonaka would say, we're not good with non-explainable AI because we just broke that part of the cycle. You can no longer get the latent knowledge. Right? And he would say, yeah, please make it explainable because that's the only way we go from the tacit knowledge of a person to an explicit knowledge that can then be shared with other person. Right? And he would say, yes, we have the web. This is going to change completely the way we combine knowledge. Right? So we can use these old schema and apply them to the current situation to say, to evaluate a bit ourselves, say, oh, compared to the dream we had 30 years ago, how are we doing, by the way? And I believe what is said also behind is that, in fact, we're not going to see symbolic AI disappear any sooner, because I personally believe that the symbolic level is the meeting level between the natural and the artificial intelligence. Right? And if you remove it, we are out of the loop. We're human. In terms of user interaction, we often think, okay, I want to give my user maximum answer, maximum knowledge. But an example of knowledge that I think we should also consider and focus on is the knowledge about knowledge, which is access right. Because as soon as you work with a company, they don't want anyone to access everything. Are we acquiring that? When I am merging all my knowledge graph, all of them, they had rights attached to them. What happened to their rights in your merge system? What happens if the graph I was only able to access is now accessible to Oscar? Did I make a mistake? Where? So there are systems to do access control over Sparkle, for instance. You can even write the access rules in Sparkle. That's not the problem. The problem is, as soon as you have the system, how do you feed this to the system? Where is the knowledge? How do you acquire the knowledge about access right? Who is working on that? Because this is a big showstopper with many companies. Some people are working on extracting licenses. This is an example of tool like Licencia that is able to take natural language description and go to RDF and try to find the closest license, and also to try to find the license that is the closest to all the licenses of all the datasets you use, because that's another problem. As soon as you combine datasets that have different licenses, what is the license of your result? So Licencia, for instance, will solve you that. But that's, again, only the tip of the iceberg. There is so much to do on acquiring knowledge on the right and licenses, I think need to be done for the past. So, fourth and last part. Am I okay on time? Yeah. The social dimension. So, why is this social dimension important? So these are the most popular social network. I am ready to bet that there is no one in this room that is not at least on one of them. We agree? Why is it important? Because they have big figures, 2.8. But it's, for the human mind, after a billion, we are lost, right? So it's important because if these were countries, that's what would happen. If these were countries, China and India would be somewhere between Instagram and WeChat. Europe would be somewhere between Facebook Messenger and Douyin. By the way, I don't even know what Douyin is. And the US would be at the bottom, right? And this is important because every time you change or do something in one of these networks, you are impacting a country of this size. So that's why it's something we must take into account. The social dimension is not only something to mine, it's something to care, right? So again, many of you have worked on an extraction. We worked in the past on extracting thesaurus from folksonomy. We worked on bringing semantics to social network analysis. So for instance, combining the social network analysis operator with the semantic operator, such as derivation, in order to provide formal definition of social network analysis in Sparkle that are able to be parameterized by the type. So for instance, you can calculate the centrality of a social network, but only considering the friends or the colleagues or things like that. So you can use the types of the network in your social network analysis. Okay, we worked on detecting communities of interest. So for instance, using 4 years of activity on Stack Overflow, we've been able to detect the different communities of interest and link back these LDA topics to link data URIs to identify uniquely for each community what is the interest binding them. So for each one of the community, we have a URI in DBpedia saying what they're talking about. But that's all good, but that's still considering the web as a source, as something to be mined, as the far west, right? What knowledge does the web really need? We, as knowledge acquisition expert, what should we do really to help the web? Not just the web for us. So for instance, I already mentioned for the COVID crisis, we worked on argumentation extraction. So it's a tool called ACTA, which uses medical publication available on the web, and from them extracts a network of arguments that is summarizing what are the claims and what are the evidence providing in the article to help the medical expert decide what to do with this article. And the same approach is also applied in the political domain to analyze the speech of politicians and the argumentation they put forward, and to see if, when they claim to have very different opinions, they really are different. Because when you boil it down to the argument, sometimes they're just saying the same thing, and you can show it. And finally, another example I really like is this CREEP European project, where they worked on cyberbullying detection, where the same methods analyzing the social network plus the tweets exchange is used to detect when a child is bullied online by other childs, and to raise other children. So, and to raise an alert with the social services and say, oh, this child is in danger, please do something. Okay? Here, we are doing something for the web or for the user, which I like. But it's not enough. The web is much more than a social media application. And when I mean application, I also mean application domain for us. It's much more than that. So, who here recognizes this beast from the 90s? You cannot answer. Go ahead, I'm guessing. Yeah, but what are these stickers? Each one of them corresponds to one thing. A method. Thank you, Natalie, you shouldn't answer that question, really. But anyway. So this is the methods. This is an ontology method. This is a knowledge engineering and ontology method. For instance, here you have the method of, this should not be usual, this, UDF, this is a mistake. This one is the paper where is defined motivating scenario and competency question that you're using all the time, right? Okay. And so the question for me, linked to the web, is, yeah, okay, but what new methodology could we imagine leveraging all the facets of the web for all the methodological steps? Because the web is a collaboration space, a corpora, a huge corpora, a set of raw data, link data, a way of doing crowdsourcing, an access to multilingual resources, an access to multiple profile of expert, even a mobile access system. Are we leveraging all of that, or are we just still considering it as a nice source of data? And it's just the beginning, because the web is now allowing us to identify everything. So I just give an IRI to any resource around me, and I can identify on the network anything I want, right? So I give an IRI to Vanessa, and she's in my dataset. I give an IRI to Zoom, and it's in the dataset. I give an IRI to your knowledge base, and it's in the dataset. RDF and link data, they allow us to distribute data on the network, and there are new approaches such as Solid that are going to go even further than that, okay? So they allow me to say, not only to talk about things online, but to link all this description together, okay? But it goes even beyond. What we're really doing is linking programs, because in fact, the web, if you look at it, its architecture, it's linking program. When you make a call on the web, it's a program calling another program. So what we are really doing on the web is building a huge network of computation, right? And we even have programming language now. Link function, LDScript is the language for programming on top of RDF, for instance. So you can link any computation through the web. And with ontologies and the linked semantics they support, we are in fact going toward an extensible network of models. We are linking all of our models. So as I mentioned, for instance, now you could represent in RDF your neural network, give it a URI, talk about it, and link it to another function which is used, or link it to another schema. You can link all of them together. What can we do with that? And the question for us, is that we are going beyond the network. It's a web linking all kind of intelligence now. It's linking us, it's linking our data, it's linking all our AI methods. And for knowledge acquisition, it means we need to think of methods and big questions in terms of acquiring knowledge for web linking all kind of intelligence. This web we are building, what kind of knowledge will it require? Access rights, profiles, what do we need to really go in that direction? And we are not doing now. Conclusion. And that's an auto-portrait. Okay, so because I'm the old monkey, I couldn't finish the presentation without the most famous quote in the domain. So knowledge is power, right? But did you ever experience it? Shall we do a small experiment? I'm going to ask you to read the next slide, okay? And let's see if knowledge is power. I know how your visual system works. I have this knowledge. Therefore, I can predict you. Therefore, I can manipulate you. Knowledge is power. Okay? And we're doing that on the web scale. What should we acquire? What should we acquire to make sure that we are doing useful and beneficial knowledge acquisition? What are the useful knowledge bases I want? What are the useful ontologies I want? What are the useful and beneficial metadata? Not just acquire for acquiring. Code is low. Lawrence Lessig, 2000. Very well-known quote in the web, just saying that every time you write an algorithm on Facebook, you are making a law for 3 billion people. They are going to live by the rules you put in that code. So when you program, you change the law for people using that. Why is it important? Because if you look at the problems of terms of condition, in fact, for instance, in the US, there was a law case between PayPal and a user, and PayPal was claiming that the user shouldn't have done something because it was in the terms and conditions, right? And they lost PayPal because the lawyer of the user said, come on, the terms and conditions of PayPal are 33,000 words, which is bigger than Hamlet. Then you have iTunes, then you have Macbeth, The Little Prince, and then you have Facebook. And you cannot ask a user to read Hamlet before checking the box and saying, I agree. Therefore, your point is invalid. Your informed consent is not an informed consent. Why am I saying that? Because I think we could position the problem of informed consent with the problem of ontological commitment. How many times do we assume that an ontological commitment has been done, but in fact it's not been done? How many of you are using FOF? And how many of you knows that the mbox property is inverse functional? And by doing that, it will have a huge impact on your base. So the ontological commitment, I think, suffers from the same problem than the term and condition and the tension between ensuring the commitment and not going in the way of the interaction. And it's even worse because the commitment comes in 50 shades. There are many ways we link things. There are many moments where we commit, so it's extremely complex. And if you allow me a little of humor, I'm going to give you my quote. I'm going to sum the two other quotes before, and I tell you, plus the problem is that knowledge encoding is a power law. Because we all have been acquiring and doing extraction. And yes, the first version of our system covers 80% of the case, and we got plenty of data. And then it takes years and years to cover all the 20 cases. It takes years, and therefore it's costly, and it's a problem. It's a problem because any project around knowledge has a cost. Okay, or even the free one has a cost. And we cannot afford. And the cost is not only dollar. The cost is also an ecological cost. Retraining your NLP model has a cost. Ask the polar bear what they think about your experiment. And on top of that, all the knowledge we are manipulating is changing. It's evolving at the speed of life. And so we have to pay that cost of owner. So I will leave you with these questions. How are we going to perform a sustainable, frugal, and affordable knowledge augmentation? Do we need to create the knowledge forgetting conference? Because we are just acquiring, but as human, we forget, right? There's a reason for that. Where is my conference for forgetting knowledge? How do I learn which knowledge I should forget? Should I work on knowledge lossy compression, aggregation, summary, and just keep what's really important? And how do I define that? How do I fight the knowledge pollution? We have more and more knowledge bases, but people are starting to spam them. Who's working on spam detection in knowledge bases? Because they're going to be spam. Ask Natasha Noy at Google what happens in the data set search engine, how much spam they got, right? You have no idea how many data sets were submitted, and when they look at it, it's just porn. How to avoid unknown, low-quality knowledge. How do we trace that knowledge? There is a work starting now at W3C on RDF 1.2 and RDF hash. I really encourage you to look at this. And in general, how to support knowledge augmentation. Should knowledge acquisition be designed to be both ways, for machine and for us? Can we reconcile a user-centric and a reusable knowledge engineering? Shouldn't the explainable knowledge acquisition be the first step to support any type of knowledge augmentation? How do we ensure we're not building digital, distorting mirror of ourselves online or other bubbles enclosing us? And so on. I have tons of other questions. In fact, I only showed you 100 slides out of 200, so we still have time. But I think it's your time. Thank you for listening.